Hi, this is Urvi, and this is my 8th puzzle game. I have two classes, a node class and a search class. The node class has a constructor for the node which includes state, parent, action, cost, and level. That's the depth, and this is my neighbors function. So if the tile is at position 0, 0, the 0 is going to move right and down. And these are the tiles accordingly. I hard-coded them. This is my move method and depends on the action. So if the action is right, the 0 is going to be swapped with the tile to its right. So this is my search method. I'm going to show you the BFS. It returns the space size, total time, and the depth. And this is the cost, the total cost, and the total cost keeps on increasing as the algorithm keeps on going on. This is my DFS, and it throws a stack overflow error. This is my uniform cost method. Similarly, it shows the goal state found, space size, total time, and depth. This is my greedy BFS method. And this is my A star method. But my A star method keeps on going on an infinite loop. Yeah. Okay. So my BFS method, here is my BFS method. I create a queue and I push the node onto the queue, and while the queue is not empty, I pop the first element of the queue and I get its neighbors, and here I check whether the neighbors are expanded, and if they're not, I push them onto the queue. So whenever it pops the first element of the queue, it is going to work on that element. It is going to print the current state, so we know what node is being popped off the queue. So for expanded, I created an array list, and every time I add a root onto the queue, I put that root into the expanded array list, and so I check whether it is expanded. So whether it is expanded, it returns true and false. So if it's false, then it keeps on going. This is my depth first search. I created two methods for my depth first search, one recursive and one DFS. So for this one, I call the DFS method, and the DFS method calls the DFS recursive. So every time I get a node, I'm going to recursively call that node and get its neighbors and check if they're expanded, and again recursively call the node's neighbors. This algorithm checks, this part checks if the program runs more than 5 minutes and then it kills it. This is my uniform cost method. So for my uniform cost method, fn equals fn equals gn. So I created a method, minimum cost node. So that returns the node with the minimum cost, and then I remove that node from the node array list. So whenever it calls the minimum cost node again, it is going to call it on the remaining nodes in the array list. So every time I call this, it gets the minimum cost node and expands that node first. So for the greedy BFS, fn equals hn. Therefore, I have a function minimum tiles misplaced, and it checks for the and it returns the node that has the minimum tiles misplaced, and expands that node before. This is my A star method, and A star method checks for fn, lowest fn, and this method minimum f returns the lowest fn, that is gn plus hn. So it expands the node with the lowest hn first. Yes, that's it. Thank you.